In Module 4, Lesson 11, we're going to factor expressions. So we're looking first of all at a model that we're going to use to answer the questions. How many 5s are in the model? So we see 2 5s. And how many 3s are in the model? There are 2 3s. Look at the similarity. There are 2 5s and there are 2 3s. So what does the expression mean, represent in words? The sum of 2 5s, or I guess I should say 2 groups of 5, and 2 groups of 3. The expression then that we could write would be 2 times 5 plus 2 times 3. Now, we're going to use the new model and the previous model to answer the next set of questions. How many 5s are in the model? 2. How many 3s are in the model? 2. What does the expression represent in words? In your student materials, you may or may not have the correct new model, but I've changed the model for you. So what we have in the new model is 5 plus 3, 5 plus 3, and 5 plus 3. Breaking it down, we have 2 5s and we have 2 3s. In words, we have 2 groups of the sum of 5 and 3. 2 groups of the sum of 5 and 3. So the expression that we could write to represent that would be 5 plus 3 plus 5 plus 3, or 2 times the sum of 5 plus 3. The next question then, is the model in Part A equivalent to the model in Part B? Well, if we move the 5s, exchange the 5s and the 3s, it's still the same. It has the same value. Is it equivalent? Yes, it is equivalent, having the same value. So when we look at the two expressions, we have 2 times 5 plus 2 times 3. That was our first relationship that we wrote, is equal to 2 times 5 plus 3. And so in 5th grade and in Module 2 of this year, you've used similar reasoning to solve problems. What's the name of the property that is used to say that 2 times the quantity 5 plus 3 is the same as 2 times 5 plus 2 times 3? And hopefully we remember that as the distributive property. Now we're going to take a look at an example with variables. What does the model represent in words? A plus A plus B plus B or 2 A's plus 2 B's or 2 times A plus 2 times B. All of those things represent our model. So what does 2A mean? 2A means that there are 2 A's or 2 times A. How many A's are in the model? 2. How many B's are in the model? 2. So then what expression could we write to represent this model? Well, we can write 2A plus 2B. Remember, this model is showing the same thing as this up above, but we mixed the A's and the B's around. So we have 2 A's and 2 B's. There are 2 A's, 2 A's in the expression, 2 B's in the expression. So the expression that we could write to represent the model is we could have A plus B plus A plus B, or 2 times A plus B. Are the two expressions equivalent? Absolutely. In the same way that they were in example 1. Example 3, they're asking us to use the greatest common factor, GCF, and the distributive property to write equivalent expressions. So they're asking us to find a common factor in each of the terms and then to rewrite it using the distributive property. So clearly I have 3 that I can factor out times F plus G. They're asking us to factor out the greatest common factor of both terms. So problem 1 would look like this if we expanded each term. We would have F, or 3 times F. Let's try that. So we would have 3 times F plus 3 times G. Greatest common factor is obviously 3. And then we simply rewrite it as 3 times F plus G. Okay, let's look at the next one. 6x plus 9y. What is the question asking us to do? Again, factor out the greatest common factor. So then we need to find the greatest common factor of 6 and 9. What is the largest number that goes into 6 and 9? And we should find that 3 goes into both of them. Now here's our answer. Let's look at the process. How would problem 2 look if we expanded each term? Let's look at it. 6 So we know that 6 times x plus 9 times y is how it would look if we expand each term. And then, of course, we can factor 6 and 9. So we'll go ahead and factor them. 6 is 2 times 3. Times x. And 9 is 3 times 3 times x, or times y. So the greatest common factor in problem 2 then is 3. We pull that out. And we use that to rewrite, which will be 3 times 2x plus 3y. Now, looking at number 3, 3c plus 11c. They're asking us, is there a greatest common factor in problem 3? Yes, c is the greatest common factor. So if we rewrite it using the distributive property, what we're going to factor out is the c. And it will be c times 3 plus 11. Now looking at 4, 24b plus 8. Well, greatest common factor, hopefully you can see that, because 8 goes into 24 and also into 8, would be 8. So we're pulling the 8 out, and 8 times 3 is 24, 3b. And 8 times what equals 8? 1. And you have to put that in there, that 8 times 1, because otherwise you don't have the plus 8 part of your expression. Now let's practice. 7x plus 7y, our greatest common factor is 7. So we'll pull that outside the parentheses and put x plus y inside the parentheses. In B, greatest common factor of 15 and 20 is 5. So we'll pull that out. 5 times 3 equals 15. And of course the g has to stay there. And 5 times 4 equals 20, and the h has to stay there. In C, we have 18m and 42n. Okay, the factors of 18, 1 and 18, 2 and 9. 2 goes into 42, but that's probably not the largest one. 3 and 6. 6 does go into 42, 7 times. So I believe we found our greatest common factor of 6. 6 times 3m will equal 18m, and 6 times 7n will equal 42n. In D, we have 30a and 39b. So if we're not mistaken, 3 is our greatest common factor. 3 times 10a equals 30a. And 3 times 13b is 39b. Okay. In letter E, we have 11f plus 15f. Now, when we say it out loud, we probably can see that our greatest common factor is f. So we're doing f times 11 plus 15. And in letter F, we have 18h plus 13h. So we can see that our greatest common factor is h. And we have h times 18 plus 13. And then in letter G, we have 55m plus 11. Well, 11 goes into 55 and into 11, so that'll be our greatest common factor. 11 times 5m equals 55m, and 11 times 1 equals 11. And then in letter H, we have 7 plus 56y. 7 also goes into 56, so our greatest common factor is 7. And 7 times 1 equals 7, plus 7 times 8y equals 56y. There we go. Now in part 2, we're being asked to evaluate the expressions. And when you evaluate expressions, oftentimes you're going to substitute and then solve. So in this case, they've given us x is equal to 3, y is equal to 4. And what we're going to do then is substitute. We have 6 times 3 plus 21 times 4. And that is 18 plus 84, which is 102. That's our first expression. Our second expression then is 3 times 2 2 times 3, which is x, plus 7 times 4, which is y. And we solve inside the parentheses first. 2 times 3 is 6, plus 7 times 4 is 28. And again, inside the parentheses, 3 times 34, which equals 102. We'll do the next one, 5g plus 7g, or g times 5 plus 7. So again, we're going to substitute. And we have 5 times 6. I'm just going to put these in parentheses, since I know that's multiplication. And 7 times 6. If I multiply them, I get 30 plus 42, which equals 72. And the other method, if I put 6 on the outside of the parentheses, and then I add 5 plus 7. 5 plus 7 is 12, and 6 times 12 is 72. And then in example C, we have 14 times 10 plus 2, which is 140 plus 2, which is 142. That's our first example. And then our second, 2 times 7 times 10 plus 1. And 7 times 10 is 70 plus 1. 2 times 71 equals 142. Now the patterns that we should have noticed was that the results were the same. And then what would happen if other values were given for the variables? So if instead of having x equal 10, if we had x equals 7, would we get the same answer? And hopefully you can see that we do. If you don't see that we can get that, substitute some different values for the variables to prove that it will happen every time. So the most important part of the lesson, how can you use your knowledge of the greatest common factor and the distributive property to write equivalent expressions? You can take problems and make them easier by rewriting using the distributive property. For example, we find the missing value that makes the two expressions equivalent. All right, in our first expression, I found an error there, fixed it for us. If your material has 14x, take that 1 off because that was a misprint. So we'd have 4 times x plus 3y. The next one, we'd have 5 times 7x plus 10y. The next one would be 9 times 2x plus y. The next would be 8 times 4x plus y. And the last would be 100 times x plus 7y. And you should have determined the missing number by finding the number that will multiply to get the starting number.